Okay, last lesson of the polynomials unit. So far we've been looking at polynomials where the coefficients out front, the leading coefficients have been positive 1 or negative 1. Now we're going to be looking at solving for the leading coefficient where it's not 1 or negative 1. So just a reminder, when we factor polynomials, we write it in this form. We have a polynomial is equal to a leading coefficient times its factors. Okay, and a few important points here. So every polynomial can be written as a product of its factors times the leading coefficient, and every polynomial's function has the same number of factors as its degree. And these factors can be real or complex. Remember, complex we just talked about as the non-real solutions. Okay, and also they might be repeated, which is where we get the multiplicities of 2, 3, 4, 5, etc. So let's take a look at this first example here. We're given a polynomial graph. They're telling us that this polynomial goes through the point 2, negative 24, and we're supposed to tell them why we can write it in this form, where we have a leading coefficient times x plus 1 times x minus 3. Where did they get this x from, looking at the graph? 0. Good, we have an x-intercept at 0. Okay, what about the x plus 1? Where's that from? X-intercept at negative 1. And here we got an x-intercept of positive 3. Okay, don't really need that on the graph, but if you want, you can write zeros are 0, negative 1, and from this factor, positive 3.
Junior class change.
So that's how you can easily write your polynomial in factored form. If you're given a graph, you locate the x-intercepts, you figure out the multiplicities. Okay, in this case, it's going straight through, so multiplicity 1, straight through, multiplicity 1, straight through, multiplicity 1. That's how you would figure out the exponents on these factors. So first find the x-intercepts, put them in a factor form, and then state the multiplicities. There will always be a leading coefficient, so you should always have a c in front of those factors. And our job in this lesson is to solve for that c. Okay, so first let's recognize that a point is written as x, y. And the polynomial p of x can actually be written as a y equals equation. So if we know the point is xy, we can sub that in. Into the polynomial. So our y is negative 24. C will stay as c, that's what we're going to be solving for. And our x is 2. So for every x, sub in a 2. And our goal is just to evaluate and solve for c. So we get negative 24 equals c times 2 times 3 is 6. 6 times negative 1 is negative 6. Divide by negative 6, and we get positive 4. So we used the point to solve for c, and now we have to write the polynomial. So we started with p of x equals c times x plus 1 times x minus 3. Now all we're doing is putting the 4 in for c. So the polynomial is equal to 4x times x plus 1 times x minus 3. Now, this is where we have to be careful. Read the question. It says expanded form. What form is it in right now? Factors form. So we have to expand this. Let's leave the 4x out front, and we're going to FOIL the two binomials. So we get x squared minus 3x plus another x is minus 2x minus 3. Then we have to distribute that 4x into every single term in that trinomial. So 4x times x squared is 4x cubed. 4x times negative 2x is negative 8x squared. And 4x times negative 3 is negative 12x. So your polynomial is now in expanded form. This example continues for every example in the lesson. It's just the question is given in different ways. So this one was given as a graph. The next one will be also as a graph, but this time they're not giving away the obvious factors. You guys have to come up with those factors. So first step, figure out what are your zeros. What are your x-intercepts? Take a look at the multiplicities and how can you write those in factored form. So p of x will equal a constant, and let's take a look here. We have an x-intercept at negative 2. So as a factor, I would write that as x plus 2. Now we just had a whole lesson on multiplicities. This is a point of inflection, so that can be 3, 5, 7, 9, anything odd. But they're telling us that this polynomial will be of the lowest possible degree, which means we pick the lowest multiplicity. So point of inflection, the lowest multiplicity would be 3. So in this factor, we put a 3. We have another 0 at positive 2, so the factor will be x minus 2. What feature are we seeing? Good, it's going straight through, so the lowest multiplicity will be 1.
Is that C that's always there?
Yeah. Yeah, just specific in lesson 7, 8, 9, they gave you all examples of polynomials where that C was either a positive one or a negative one. So this lesson is looking at different scenarios where we don't necessarily have one or negative one. And we have to solve for it. Okay, so in the last example they gave us a point. This example they didn't. Can you guys find another point on the graph that's obvious? Which one, Chris?
Oh,
You were just agreeing?
Does it matter if there's a 0 in it, or does it have to be like the vertex? Like, could I say like?
So I will tell you, you'd never want to use an x-intercept. But is there another point?
Like a y-intercept? Can I use a y-intercept?
Y-intercept, perfect. And I'll tell you actually why that's ideal. First of all, be careful. If you were to look at this quickly, you would think 0, negative 2. But what's the scale?
Ooh,
I think
easy.
4. So it's going 0, negative 8. So be really careful if you're given a graph. Nolly, can you put away your phone, please? Thanks. So, when possible, pick a point, and when possible, pick the y-intercept. And the reason why is because when we sub in the value x and y into our equation, the x's all become zeros and our calculations are really easy. Okay, so we wrote out our polynomial in factored form, we figured out a point, now we're going to sub that point into the polynomial. So p of x or y will become negative 8. C is what we're going to be solving for, and all my x's turn to zeros, which make my calculations very easy. So on the right hand side, 2 cubed is 8, 8 times negative 2 is negative 16. Divide by negative 16 on both sides and we get a half. Once you find your C, you're going to replace that into the polynomial. So the equation in factored form for the polynomial shown will be p of x equals 1/2 times our factors, x plus 2 cubed times x minus 2. That's our final solution. So we've seen two examples where the graph is given and we can create the equation just by looking at the zeros, figuring out the multiplicities, solving for the unknown leading coefficient c, and plugging it back in. In this next example, they're giving us some information. So rather than looking for it on a graph, they're pretty much giving it to us, which is pretty generous. So determine the equation in factored form of a fourth degree polynomial function which passes through the point 1, negative 12 and is tangent to the x-axis at 2, 0 and at negative 3, 0. So first of all, when y is 0, what can we call these points? X-intercepts. Okay, so it's important to know that these are x-intercepts to start this question. And they're telling us that these x-intercepts are tangent, which means the multiplicity will be minimum what? 2. Now they're telling us it's a fourth degree polynomial, so will these for sure be tangent with multiplicities 2? Because 2 plus 2 is 4. Okay, if they told us that the degree was something else, then we would maybe have to go higher in our multiplicities. So let's start out with our polynomial, given the information we know. Okay, we're solving for our unknown leading coefficient. And we have two zeros that are tangent. If we added these multiplicities, we would get degree 4. The first zero is at 2, which means the factor is x minus 2. And the second one's at negative 3, so we have x plus 3. We're given the point xy, which is 1 and negative 12. So we sub that in. Sub in point 1, negative 12, which is your x and your y. Okay, so p of x or y is replaced with negative 12, c is what we're solving for, and all your x's turn to 1s. And we'll just evaluate a little bit. So 1 minus 2 is negative 1 squared, we get 1, and 4 squared is 16. So divide the right-hand side and the left-hand side by 16. We get negative 12 over 16. And you always want to reduce, make sure you do that. So divide both the numerator and denominator by 4. We get negative 3 over 4. That's our leading coefficient. And then we just plug that in. So replace c in the polynomial. So we got p of x equals negative 3 over 4 times x minus 2 squared times x plus 3 squared. So let's pretend you don't have a calculator. We have a fourth degree polynomial. Let's pretend you don't have a calculator and I ask you to draw this. Okay, fourth degree polynomial. Will the arms be together or separate? Together. And we have a negative leading coefficient, so which way will the arms be pointed? Down. Very good. Alright. Pretty much same question, just asked again in a different way. We have a fourth degree polynomial. It's passing through the point 1, 2, and it's giving us 4 zeros. So if we have a fourth degree polynomial and they're giving us 4 zeros, what is the multiplicity on each 0? 1. You guys are awesome. So we have p of x equals our leading coefficient, and we have to take our zeros and put them into factors. So we get x plus 1 from 0, negative 1. Okay, we get a factor of x from the x-intercept 0. We have a factor of, what do I put for 3 over 2? What's your factor? What'd you say?
2x minus.
Yeah, 2x minus 3, good. Hey, now technically if you put x minus
I'm not-
3 over 2, that would be okay as well, but if you can write it in this way. And then the last one from our x-intercept 2 would be x minus 2. So, thank you, Joyce.
Yeah, thanks. How are we doing?
Yeah, you too. Bruce, what's my next step? I know you are. That's why I'm getting you to pay attention. Okay, we have a point, x, y here. We've got to replace the x and y in this equation with the point. Okay, so this is like a y equals
Yeah,
here.
so 2.
So 2 equals c, and all the x's will be, yeah, be replaced with the 1. So let's solve that out. We get 2 times 1 times negative 1 times negative 1. So what does c equal? 1. So this is the only example in this lesson where we actually got a leading coefficient that was 1 or negative 1. And in summary, our polynomial would be x plus 1 times x plus 2x minus 3 times x minus 2. And just for completion's sake with this lesson, just don't forget to put that c in front. If it's 1, you don't actually need it, but I just want to make sure that these steps are clear. You always put the leading coefficient out front.